Astronauts to the moon.
Ignition sequence start. 3, 2, 1.
Houston, we have a problem.
Liftoff. We have a liftoff.
We copy you on the ground. You got a bunch of guys about to turn blue.
What you're seeing here is a mirage.
So that's kind of what I wanted to start out with, and in honor of that, like I said, I kind of wanted to highlight some of P-Brain's work. But before that, I think, Jeran, what I want to have you do, and you've brought this up and even made videos about it, about this mysterious thing that we have called our, that you're terming our dome of vision, right? Can you talk about that a little bit?
Sure. Yeah, I call it the personal atmospheric dome, or the PAD. And here's the thing I think people miss is that this is not a theory. It's not an idea. It's the truth. It's a fact. And you can figure that out on your own by just simply knowing that if you look up, that's the least amount of atmosphere that there is right above you, straight above your head. So if any light is coming directly down from straight above you, that has the least amount of refraction. It has the least amount of effects. Those rays are going to come at you parallel if the sun's right above you. And then if you look to your left or right, or straight ahead of you or behind you, that is the most amount of atmosphere. So right away you can tell if the least amount of atmosphere is above you and the most is to your sides. That creates a personal atmospheric dome. We all see through it. No matter where you're at on the Earth, no matter North Pole, South Pole, wherever you might be, you exist inside of a personal atmospheric dome where everything renders to you. So nothing can just appear in the sky. It all has to come from far away. So that's why we see things come up from the horizon line, right? And so this is a dome. We see as a dome. And if you think of the sky being a plane above you, so a plane of stars above you, as things get further, since you're looking through more and more atmospheric distortion to see them, things appear to bend down towards the horizon line. And so that's the personal atmospheric dome. And when you understand that, and you realize that no matter where you're at on Earth, you see the sun rise to the east of your personal atmospheric dome and set in the west. And so people get very tripped up and they say, well, what about in the south? Isn't it the opposite? Where it's just, no, they are looking north. And so things rise on their right and set on their left, whereas us in the north, we look south and things rise on our left and set on our right. So it is a personal atmospheric dome. And then you have to learn to understand that. So many people get caught up in the idea of here's the fooling part. You live in a personal atmospheric dome. That's what you live in. That's what you see things through. They convince the world that there is another personal atmospheric dome below you with somebody living upside down inside it. And that's the biggest fooling point of the entire thing, is that no, you exist in your personal atmospheric dome. That's how you see things. When you watch a plane fly off into the distance, it doesn't just fly straight up and then disappear into the clouds. It goes down towards the horizon. That's the way everything works. Just like the sun sets, just like the moon sets, just like the sun rises, just like the moon rises, just like a plane coming over the horizon, as you might term that, but just means it's coming from far away. I can't see planes from where I live leaving the San Francisco airport. It's too far. But as things get closer to me, I would see them appear not out of the middle of the sky, but from the horizon line, because it's finally rendering itself to me. It's big enough to come into my personal atmospheric dome. And that's the way the entire world works around you. It's hard to explain, I guess, the personal atmospheric dome for people to get, but one visual that I thought was really good is if you picture a really foggy day, so it's extremely foggy, and you're at a train station and you're reading the train schedule, and you would only be able to see, let's say, you can only see your own train schedule. You're looking at it, and if you look any further, it's too foggy to see. So, but if you think about there being 10 other people at this train station at the same time, and everybody's looking at their own little document, well, they can read their own little train schedule, but to all of them, they can't see the other people around them. That's how the Earth works. That's how our atmosphere works. That when it's clogged up, like when it's foggy, you can't see very far. When it's clear, you can see a little bit further. But that's the same thing, is that we know that people exist, or other people are at this train station, other people are reading their train schedule. But in your personal atmospheric dome that's fogged in, to you, you're all that exists. You look left, right, behind you, in front of you, and that it's all blocked. But we know that those other people exist. It's the same thing when two people on flat Earth are standing near each other, maybe 4 or 5 miles away, but to each other, the horizon ends before you can see the other person.
Right. So like if I'm looking off towards the horizon and I see the blue sky and the clouds towards the horizon, the clouds in the distance look like they're stacked on top of each other, basically. And if I were to picture myself as a person that's directly underneath those clouds in the distance, they would look back in my direction and see the blue sky with all the clouds stacked on top of where I'm at. And so it is very much a subjective sort of personal atmosphere that we all live within. We don't necessarily see it or understand that it's there, but it's almost like we're all walking around with our own little like you said, personal atmospheric dome. I mean, that's really the best way to put it, that travels you around wherever you go to varying degrees depending on the weather, really. Right.
Yeah. You remember, John, me and you were saying this back 2 years ago when we were talking about being on, I believe it was a pool table, and saying that each person had like a glass, a glass you would drink water out of, upside down above them.
Yep.
Yeah, and that's really the way it works, and you're absolutely right. Same thing with colors. So when you watch a sunset and you see that the clouds near where the sun is setting are red or purple or pink and looking really pretty, if somebody is that distance away from you underneath those clouds, they don't see those colors. It's a very, very personal thing. You see the colors of the sunset because of the clouds and the atmosphere you're looking through. Somebody who's standing underneath that cloud would look straight up and see nothing but a cloud. Wouldn't be red or anything because that's not rendering for them in that color.
Yep.
Yeah.
And I think that's the biggest problem with the ball earth theory going back in history, is people failed to sort of jump outside of their own heads to see, how would things look without the atmosphere. But refraction really wasn't even understood until the 1600s, but it appears the ball earth theory had already taken hold at that point. But nobody went back to revisit, this assumption that light must always travel in straight lines, but we know that it absolutely does not.
Yeah, I totally agree with I'm looking at the chat right now, and I saw that Flat Earth Logic says everybody who has a smartphone camera should post a video of this observation with a limited viewing angle. It's very simple. You could do it on a long street. You could do it in a warehouse like a Home Depot or a Lowe's, and you can easily see this. And the argument that I've heard from ballers is hilarious. They're calling people morons and saying it can't possibly happen because their model shows it doesn't. And then their claim is that the road or the floor that we're doing these observations on is bumpy, that it's curved.
If you allow me, I can share one more time a few slides of
Sure.
refraction and geometrical perspective. Is so much going on behind the real life, the material world, and when you're talking about light, is something that even for the actual science is really a mystery. I mean, they are trying to discuss if it's a particle of a wave. So that is how the actual science fight trying to understand light. And because you must be seen in that way. But for me, is like when you even have the own words from Mike West saying that, I must be assumed that the radio of the Earth is, growing up based on the object that you can see far away, because in the standard model doesn't match. And he admit that, that is not something real, it's just a theoretical thing, trying to match the observations, like if you live in the globe and not, it's not a fixed globe. Right now it's like an inflate globe, because you need to making growth up based on that distances. But the real thing is that they transfer the standard refraction to a geometric non-existent curve. So they make just simply statistics for saying, okay, if you see an object that far away at that height, is because the globe grows a certain percent. But when this is my research, just like that, because for me, when I start to look at this kind of video at that time, because this is like a 2 year ago video that a woman filmed on the shore, on the shoreline, a sunset, right? So for that person filming the sunset, if she doesn't have any optical device, optical instrument to make a zoom, because our eye is a magnificent piece, of intelligent design, but we can make a zoom. Your eye is a fixed distance range. So for the normal people, you're gonna say that like the sun is here, right? Where my mouse cursor is pointing.
Mm-hmm.
But when this woman make a zoom, you can clearly see two sources of light right away. You start to see this, glowy source of light, and you're gonna see this other source of light. So the woman asked, because maybe she turned around and said, "Hey, look, that is the moon. So that object in the sky is not the moon."
It's Planet X.
Exactly. And this woman, and I say exactly because this woman is like, a Nibiru believer. So she's filming without notice that is exactly when you're talking about apparent position and real position. And that is, if you start study this phenomena, for me, and this is my interpretation, just like that, this kind of thing, you can recreate in computer based on a personal DOM situation. Because when I look this, for me, it's clearly, this is the actual position of that object. And this is a refraction, because this is glowing up based on the volume, vapor on the clouds. It's like, this is like the mirror of the glass. And this is more real position of the light source, okay? Mm-hmm. So this is one example. Let me just show one more that comes from a video from Antonio Subirat that he presented a few months ago. And let me just skip to that moment. So here you can see, again, a few examples. Let me just skip a little bit here. You can see, oh, that is the source light. But suddenly from the bottom of the video, you're going to start to see that another sun rises up. So what I'm trying to show with this is like, we must believe with atmospheric refraction and reflection of the light. So it's not just a theory or our interpretation. So you must be recognized that something happened based on the behavior of the light passing through, fluid, in this case, the atmosphere. So you're gonna have here another example. Let me just skip forward. This is again in the seashore, where you're gonna see here in the background. Let me see. That is the first source light appear, and a few moments later, you're gonna see like there is appear another one to the right side, and even respect the the distance, because I mean, I don't know which one is the real actual light source.
Right. So
I mean, I just show these three examples, not for keep only one example. I'm trying to, prove that there are out there really many of these kind of, natural behavior when you trying to explain light through a media. So when I trying to translate this in my own language of visual computers, I'm start, with this. First of all, with this NASA understanding the astronomical refraction, which is, official document come from NASA. And I showed this before, so sorry for the guys out there that maybe remember this. But the observatory, based on astrophysics data system that NASA use, they suggest like anything about 20 degrees from the horizon line. So this gradient is, is unacceptable, like a real thing. So that is just the beginning of this document. So any people out there which is a globe head and they don't have this into account, they are even refuse the religion, because this institution says like you must be considered the surface on the flat earth and the refraction occur at the top of the slab of atmosphere. So
Wow.
that is from a document. That is from a document of NASA. And even, I don't have in this video, but we have here, for example, in Argentina, we have a similar document, but it's in Spanish, that when you trying to understand the refraction, you must be again take into account that the surface of the earth is flat all the time, parallel to the observer, like real life we see. But the problem is in this gradient, and it's not a fixed gradient. I mean, if you are in the seashore, you're going to have that gradient of distortion. If you go up in the sky, for example, to the mountain, you're going to have the same thing. So what is telling that? That is telling that is personal view phenomena. It's not a fixed something that you have in the same area. It's just based on your own view, because it's happened all around the world, and it's happened even if you are with the camera touching the floor, or if you are in the tripod, or even like you're gonna see in a moment, even if you go up into a mountain where the astronomical observation is, the best thing that you can do, you're gonna have that distortion also at that same gradient, but 3,000 meters up. So that is telling you this is local to you. It's not a fixed thing.
Exactly.
I don't know if you are follow me.
Oh, absolutely, we're following, and this is exactly what Jeran was just saying. This all goes back to your personal the pad.
Exactly.
Right. It's exactly it. And even the two suns, I noticed, are both bringing reflections down the water, right to us, the observer. And somebody standing 100 yards down from that, if they were on the beach, would see those exact same two reflections coming down at them. Each of us is rendering our own personal observation of this. Very clear.
Exactly. So I take this explanation and these observations, and I make a simple computer simulation. And this is, I want to leave clear, because it's a simulation. It's not an image representation. I mean, it's not based on, I'm going to make this beauty. It's just, I'm going to use the properties of the 3D software that uses Snell law and other laws of physics to simulate what is going on. Okay, so that is the difference between drawing in just a paintbrush or in Photoshop or in CAD or any other that software that you must recreate for your own the lines or the behavior of or the result of an optical distortion. No, this is compute for you based on the actual science equations and laws, right? So what I did was just simply, I create an atmospheric, personal dome, like we call it, and I put just a reference object, just for the camera see something, and I put 4 cameras, one which is inside, looking forward, looking to the front of this personal dome. What you see here is a camera inside that personal dome, pointing to that place, to that direction. And then I put another camera outside, like if we have that capability, to get out of our plane of existence and see the things from outside. I wish that could be possible, but we don't know. We know that is the case. But I put that camera outside, and this is another camera also outside, but a little close to this personal dome. And I create a volumetric light. It's not just a light. I create a volumetric based on Arnold render, which is and rendering shine that is in Hollywood standard because it's really accurate. It's one of the most accurate software renderings in the market. So it processed, this is a volumetric atmosphere, and this is a light source, and here you can see the inverse square law with the, you know, this is the source light and this is the decay of
Beautiful.
that intensity.
Mm-hmm.
So what you want to see is just the light move in a straight line, in a straight path, you know, from the back to the front, because this is like the side view, but it's going to come from this part, from this back is going to go forward to the front. So if you're looking in geometrical way, what you're going to see is, first of all, the person inside this dome, when the sun is always in a straight line and always above the surface of the earth, but the person inside this bubble, this person is going to see coming from the behind the horizon, because if you see here, look where is the spotlight here is touching the horizon line. So people inside here, person inside here, looking to the sun, for that person is like the sun is come from down to up, but that is not the case because the light is always above the surface. It's just that atmospheric distortion that produces that kind of situation. So as long the light is traveling in a straight path, you know, back to forward, you're gonna have, for example, the azimuth position where the light is on the top of that person that is, you know, 12 o'clock. If you are at that moment in time and in space in the earth, you're gonna look up and gonna see the light source up, you know, to your view, and that is 12 o'clock. So that is the most, you know, technically speaking, the most accurate light position, because you have it, you know, in your top view.
Yep.
So when the light continue, if you look outside the personal dome, you're gonna see just, you know, without any kind of distortion, the light travel in a straight line. But for example, in the personal dome, you're gonna see like you're gonna feel or see like that light source start going down, but it's never going down. It's just perspective plus the atmospheric refraction.
Right. And Iro,
So
let me interject one thing here. And this guys, what Iro is demonstrating right here is precisely how the mainstream is trying to fool you by omitting the perspective. In other words, they will do their geometry, their trigonometry based on the outside view of what's happening and completely omitting that dome down there of perspective. That's how they'll fool you. That's how they'll try and prove to you that their math cannot be wrong, because math is reality. Unfortunately, their math isn't wrong necessarily from that particular perspective, but from the perspective of the person, it's completely wrong. And this is where they deceive us. Continue on, Iro.
Exactly. In fact, something that is very important also to understand, and you can see here, you know, in the computer simulation, is that when you're leading with objects is one thing, but when you're leading light passing through a media is other thing. And I refer to the size. I mean, when the conditions are, you know, the standard conditions, the light source is not going to reduce in size. It's very, you know, it's not the common situation that the light, when it's going out, is going to reduce in size. In fact, that not reduced size of the light source is going to be more clearly if you make a zoom camera. If you leave the camera really way back, you're going to see a little change in size. But if you make a zoom, you're never going to appreciate that, because the light source is filling the volumetric, you know, fluid of the atmosphere, and is going to disappear based on the atmosphere layer before you are going able to see the reduced size of that light source. I don't know if I explained correctly, but what I'm trying to suggest is like here, remember, this is a person inside the dome, and here you can start see how the circular shape of the light source, and remember, this is not a geometrical object with self-illumination, shader. This is a light source. This is the light source calculate as a light source, not as geometrical object, because the people like trying to say, hey, look, the sun never reduced in your model, and they draw into a CAD software. They just simply create a circle. They don't work with light. They create a circle, which is a geometrical representation of the sun.
Excellent.
But this is not a geometrical object. This is a light in a volumetric computation. So when the light starts going away, you're gonna see light always goes in a straight path above the surface of the Earth, but start to appears to go down inside of this personal dome, and even you're gonna squish a little bit, like in real life, like you see there.
Yep.
You just see, for example, right now for this person, the sun was cut off in the middle, but in the real life, if you have the capability to go outside, you're gonna see always is above the horizon line. It's just the refraction of the atmosphere that reduces the velocity of the light. And here you also can see where the sun is to the person inside here. So as the light go away, the person here never is not able to keep seeing that source light, but always stay on the above the horizon. So if you look it here again, you can see based on the NASA astronomical and astrophysics data, you're gonna see that the person inside that dome is gonna see the sun passing by and reduce and squish based on this gradient. And again, this is a computer simulation. This is not a geometrical representation.
Yeah,
this is a computer simulation of the light.
Provided by NASA, guys. There it is.
Yeah. In fact, I download that document from the Mike West Kerr calculator links. I don't even, turn crazy trying to find that.
That's awesome.
There you have it.
Beautiful.
So another thing that prove that we must be take into consideration all these phenomena of the light is, for example, this is a screen recorder from my C4D Cinema 4D 3D software. Here is the point light source of the Arnold render and shine, which is this. So this kind of lines, it's where the light is in the rendering. So I mean, this is not a sphere representing the sun. This is a light rendered through an atmospheric layer. Because right now, if you look at this, screen capture, this is like a CAD program. So these people show us the calculation and observation and measurement in this kind of view, but they never hit render. And when they hit render, they don't use a volumetric software. So it's the same thing as this, like the only difference is like instead of showing just wireframe lines, it's gonna show you colors, but you never compute volumetric light. So these guys are, really a poor understanding of how 3D software works. So when you hit, in this case, I hit render, but I hit render in this software that computes a volumetric light. So that is why this just simply asterisk you're gonna see as a light representation with the inverse square law situation, That is why the normalize check button is on, because when you normalize the light, you apply the inverse square law. If you don't, if you want to recreate like science fiction light, like reach the confinity of the universe, you uncheck this and you're gonna have an unrealistic light behavior. So if this is your personal dome and the condition of the atmospherics are right, you're gonna even have which is called anisotrophic light conditions. And that is really strange cases, but it happened in real life, and that also show us that these atmospheric phenomena are really present in real life. So what I did was recreating this as an atmospheric volume. I moved the light in a straight path. You can see, you can imagine, based on what I explained before, that a person inside of this dome is going to see the light going down when it's always going in a straight path. And you start to see this kind of deformation. Of course, what I'm trying to explain in this simulation is what we see in real life. When I enter to the volume of this, with to the shader of this glass dome, and I start to increase the slider to compute the anisotropic calculations, you're going to start to see like one source light can mute and transform into a ring light, like we see in real life.
Wow.
And that is what only one light source. But what I'm trying to understand, even the rainbows you can compute with this kind of calculation. What I'm trying to prove is like all these phenomena in the sky is based because we have like a glass on top, based on atmospheric conditions, or maybe a mix of atmospheric condition plus a real glass. I don't know, because I never see it. I am not fan of the dome, theory, because I don't see it, and I can explain the same behavior based on the accumulation of atmospheric layers, just simply as that. But what I'm trying to show is this: is we have that in our sky. We have that personal dome because it's the way that the lights travel or propagate and behave with our world. So here you can see why in regular science is always talk about apparent position of the lights and the real position of the light. And of course we never can reach the real position of the sun because we are not able to go and see that. It's simply as that. And for finish the presentation, I showed this a few times before, but when you go to a lab and try to recreate the Fata Morgana effects or the atmospheric refraction effects, all the time you must be lit with straight objects always above the an horizon, because if the object is totally behind or occult behind the horizon, you're never gonna recreate this kind of real world situations. This is a superior mirage and inferior mirage, and Fata Morgana effect. And let me go a little more. Let me just explain this very quickly, because I believe the video has the line, but it hasn't. Here is the camera. You can see the camera in this video, but to the right side is the camera pointing towards this paper object and looking through a recipe with water, salt water and sweet water, regular water. But the camera, the atmospheric simulation, and the object is always at the same level. This paper is not down of the actual view of the camera and rise up like they trying to explain based on the Canigou effects or other object that is completely hidden behind the horizon in the spherical model and rise up. That you never can recreate, So let me just go a little forward. For example, I took this image from a movie, the Thomas Crown case, and here you can clearly see when the camera, there is a crane camera inside of the boat, and the camera just lift up and show more panoramic background, and then comes into the boat and film the character of the movie. But here you can clearly see how the building disappear and reappear based on the atmospheric refraction and the perspective and the height of the camera, but it's hiding behind an atmospheric layer. You can clearly see here. It's not because the camera go away or the sphere is growing up at that moment. I mean, it's just simply as that. It's just simply as that.
Okay.
That is, if you want to wrap it up, I mean, there is no any geometrical curve. It's just these guys took all his their understanding and they create a chart and they transfer standard refraction to a geometrical curve that doesn't exist. It's just simply as that. It's a chart-based model.
Okay, beautiful. All right, that's brilliant, Jeran.